I've thought about this a lot, and I think it has to be. That has to be the case, that your odds of finding civilization that is intelligent but is not dominated with AI is zero.
Welcome, one and all, to the Cool Worlds podcast with me, your host, Professor David Kipping. This week, it is my great pleasure to be joined by Hod Lipson, who is a professor of engineering and data science at Columbia University. There, he is the director of the Creative Machines Lab, and, by the way, has also co-founded 4 companies on the side. He is an expert on a huge range of topics, from artificial intelligence to driverless cars, from 3D printing to the future of advanced robotics. In fact, he's even co-authored 2 award-winning books on these topics. Those are Fabricated, The New World of 3D Printing, and Driverless Intelligent Cars and the Road Ahead. So his work includes so many topics that I think we're all thinking about in modern society right now, such as the dawn of self-replicating, self-learning, and even self-aware machines. And so for me, this was a very timely conversation, and I think for many of you, you will enjoy hearing about it, particularly at this point in humanity's history as we explore these challenging questions. What does it mean to be human anymore? What does it even mean to be alive as these intelligent machines start to become an integrated part of our society? So please do enjoy this conversation as we explore the boundaries and the future of artificial intelligence. I first encountered you, we were just talking about before we got started, you gave this wonderful lecture about Eureka many years ago.
That's right.
And Eureka is a way of a machine discovering physics. It was really mind-blowing at the time. This is already 10 years old though, but just maybe we can start there and talk about the more recent innovations with that. Tell us about Eureka for the uninitiated. What is it doing? How can a machine discover the laws of physics?
So the idea is with Eureka and some of the work that we did before that was to sort of use evolution to basically breed laws of physics. Okay. So the idea is basically, we do this actually naturally. We come up with all kinds of hypotheses. Here's an idea of a law of physics. Let's see if it fits data. And it's more than just fitting data. You can propose experiments, and hopefully the data from these new experiments will refute some of the laws. In fact, you want to propose experiments that deliberately create disagreement between predictions of competing hypotheses. That's the basis of scientific discovery. So that's what the machine does.
And how does it make that initial, it just guesses a random combination of symbols and things?
Exactly, random combination of symbols, completely random laws. Of course, they're all wrong, but some of them are slightly less bad than other ones.
Okay,
and then it looks for, what is the next experiment to do that causes the most disagreement between these laws. Okay, so it's going to be some point that these laws really disagree about what's going to happen, and that's the experiment it either does physically if it's connected to a experimental system, or if it's an observational system, it goes to the database and looks for the data point that's closest to that disagreement. And the important thing, it doesn't just fit to all the data. It just looks one point at a time, and that point has to be the point of maximum disagreement. So it's actually sort of, it doesn't see the entire observation at once. It just has to ask for something, and it gets that. And this is really, really important, that it doesn't just fit to the entire data set. It just creates hypotheses. So it does that literally billions of times a second.
Wow.
Creates an hypothesis, and looks for a data point, and then adjusts and creates more hypotheses, throws some out. And if you do that enough times, it's surprising what you get. You get pretty good, for things we know, we get the answers that we expect. And for things you don't know, you get interesting new things. Now, are these results the truth? I mean, who knows? You look at this, you rub your chin and scratch your head, and if it makes sense, it makes sense. If it doesn't, then you ask yourself why. I mean, it's a tool.
It feels a little bit like when you play chess against the computer. At least I don't know how the current chess algorithms work, but it was really a brute force approach, right? It would kind of calculate every possible chess move it could possibly do, 2, 3, even 100 moves ahead, and then it would just choose the one that leads to the most successful outcomes. If it's trying, there's obviously a little bit different to how the human mind would work with this problem. And is there a transition with the new wave of AI that we're seeing to move away from this kind of brute force approach, or is that still underpinning a lot of how these creative physical inferences are happening?
I think what's this idea of the really important thing about Eureka at the time was this idea of adversarial learning, which is now very, very common actually with the modern AI, is that you don't just try to fit a model to data. You have two things competing and challenging each other at the same time. So what we did back then with Eureka was we had models that fit a small subset of the data, and those subsets of the data moving around to try to defeat the model. This is where you look for that data point that the models disagree about the most. So these data points are trying to defeat the models are trying to explain away the data, and they sort of have this antagonistic relationship between them going back and forth. That's called adversarial learning. It's at the core of a lot of the modern AI techniques that we see. All these generative art, all of that behind the scenes is typically two AIs arguing. If, for example, if you look at deep fake photos behind the scenes, there's one AI that creates photos, and the other AI tries to tell if they're real or fake. And in the beginning, the one AI creates garbage. It doesn't even look remotely like a photo, but the other AI cannot tell the difference between garbage and a real photo. So it's the blind leading the blind. They don't know how to do it, but after doing this for millions or billions of cycles, they get very, very good at it. One creates really, really good photos. The other one can distinguish between a very good fake photo and the real thing. And they both challenge each other, and they get better. And this is the same thing we did back then with Eureka, but sort of for a scientific.
I guess in that case, then it's you give it the symbols, the variables. So this could be like distance, time, velocity, things like this. And then you must also tell it some boundaries, some rules. So it's only allowed to use maybe 100 symbols. Is there rules like that, or there's certain operations it can use? Right. Maybe multiply, addition.
Yeah.
So you
have to give it the alphabet.
Okay.
Okay. Here are the variables you can use. You can use plus, minus, divide, multiply, exponents, and if you get, when we wrote the software initially, we gave the user this. A menu, and there was a button, select all, and people just said, try out everything. But that turns out that's not a good approach, because the more operators you allow, the search space increases exponentially.
Okay.
And so you want to actually, this is where you come in as a scientist and say, look, this is a biology data set, so sine and cosine are not relevant. There's no sine and cosine in biology. Take that out, but there's other things. So you bring in that kind of knowledge at a higher level, and you shrink the search space, and then it works.
But presumably that was 10 years ago when Eureka came on the scene. Machines have obviously improved massively over that time. It's presumably getting easier and easier for you to explore larger and larger volumes. And I guess one question I have in mind as a physicist, thinking of like general relativity, we had to invent new mathematics for GR, like tensors didn't really exist and were really developed in hand. And think about even calculus was developed by Newton in part because he needed it to solve celestial mechanics. Is there, obviously this is not something that is happening right now in Eureka or its derivatives, but is there any hope of getting to that very high level of competing with how a mathematician would think about these problems?
Well, I would say there is hope, but we've actually done some of that. So it goes even one step further. So there's one step further, which is to invent new kinds of physics, or to transform the data in some new way that makes it reasonable. to understand. But I think a deeper question that bothered me for a long time when we did Eureka back then was, okay, we measured a couple of variables for a double pendulum, which we published our paper with. We measured angle and angular velocity of the two arms of the pendulum, and then it found the physics. It discovered a lot of physics. But the question back then was, how did we even know to measure angle and angular velocity? I mean, it's not an obvious thing. If you, on a double pendulum, okay, we study physics, we know that angular velocity is an important thing for describing a dynamical system. But
it's like the physicist's intuition was helping out there
exactly,
that it doesn't have.
Exactly. Yeah. But how did we know to measure that thing? And if I show you some other dynamical system, I show you an anthill with moving ants, what do you measure? I mean, what's the variable to measure? So we did this is just recent paper where we said, okay, we're just going to show the machine a video, just a video stream of a dynamical system, and we're going to ask it, what are the variables? Once you have the variables coming up with a physical law based on these variables, I think that's the easy step.
So you don't tell it frequency, angle, none of that. It's just
a
the
raw
video
feed. Just a raw video.
Okay.
Okay.
That's amazing.
Okay, and ask it, what are the variables? And what are the variables that describe the system? And the way we did this, so it works, but it works in the answers is not what you expect, right? so for example, we gave it double pendulum, we showed a raw video. The way we did this is we said, okay, you take the 2 frames of the video and you have to predict the next 2 frames of the video, right? And you have to do that at many scales. In the next 2 frames at a millisecond, or the next 2 frames at 100 milliseconds or something like that. So it has to make these predictions, and it does it very well. So it can predict the next frames of the video. So now they can predict the video. Okay, if it can predict the video well, it must understand the physics. It's there inside this huge neural network. It must know something about how a double pendulum works. Now we have to extract those variables out of that system. So we force that neural network, we throttle it into like a bow tie. So it can go it has to predict the next frames from the previous frames, but it's only allowed to communicate 4 numbers or 5 numbers or 6 numbers. And for a double pendulum, you can see that if you allow it to communicate 10 numbers, it can do it well. If you can communicate 8,000 numbers, it does it really well. If you allow it to communicate 4 numbers, it can do it. But if you allow it to communicate 3 numbers, it can't.
Okay, so you can tell that 4 is the minimum number.
And there's some clever math that you can do to get to that number right away in a very, very kind of, it's sort of the dimensionality of the manifold that this network is sitting on. But the bottom line is you kind of squish it and you don't allow it to communicate more than 4 numbers. And once you force it to go to that 4 numbers, those 4 numbers are the variables.
Right.
That's it.
Yeah.
Now, it's not unique. It does not choose angle and angular velocity. What does it choose? It chooses something else. And this is, we don't know what it chooses. It's sort of like going to an alien intelligence and ask them, they might have physics that uses different variables. They don't have to describe the world using the variables we choose. And so it chooses some other variables. It can predict the future perfectly in that world. But the variables are not something that we have any intuition about. So that's what we're stuck with right now.
Can you even relate? Is it just all kind of hidden in this black box, or can you relate what it thinks of the variables to the variables that a physicist would assign?
Yeah. You can see for every frame what's the value of these 4 variables.
Yeah.
You can plot it as function of time. And we tried everything. We say, is this energy? You could describe a double pendulum with kinetic and potential energy of each arm. It doesn't have to be. Maybe it's the square of the velocities. We can create a neural network that goes from what it describes it to the way we want to describe it, but it's not something intuitive. So that's the next step, is to try to understand how it thinks about physics. But it is able to do it. And so it works for a double pendulum. It works for, and we pointed the camera at a fireplace, and it said this in all this fire flames, 24 parameters. Variables describe the whole thing.
A fireplace is 24 parameters.
That's it. That's it. That's at least that's, you can describe all of it with just 24 numbers.
So the dynamics. Originally, there's obviously like every pixel is a data point. So there's like thousands, and you've reduced those thousands down to just some combinations of the pixels, essentially, which is those four numbers that it's playing around with.
Yeah, exactly. So, but the fact that it knew that it was four for a double pendulum was, to me, the amazing thing, because I don't know what kind of intuition Newton had to have to understand that there is such thing as acceleration. I mean, we take it for granted. Acceleration is a parameter you use to describe a dynamical system. I mean, nobody else talked about acceleration before that. I mean, or velocity even. I mean, velocity, maybe people had an idea. But I think if you look back at great physicists, the biggest contribution, I think, is not the laws, it's the variables. Thinking about entropy, thinking about these new variables that describe a system, that's I think, the energy. I mean, energy is a concept that's fairly new. I think it's about 200 years old. I mean, this is... to come up with these deep concepts, that I think is much, much deeper than the actual formula that connects these variables. So
there's so many questions in my head hearing about this amazing tool that we could, imagine using this on galaxies and on exoplanetary systems and things, which would be really fun. I'm kind of curious, come back to the pendulum case, that's obviously a fantastic success. With the fire, I mean, you could say it's 24, but I don't really know of a physical model where we could say, oh, you need 23 parameters, so it's pretty close. Are there other physical systems where it's hitting the right number?
Yeah, so we've tried it with a couple of mechanical systems, both real and simulated, that we know the answer, like a double elastic pendulum, with springs hanging out, sort of physics 101 type things, and it gets the right answer.
Wow.
But we have to try it on other things. But the idea is that this feeds on massively parallel data streams. So cameras, a video stream is a good thing. Any radar, I mean, any kind of massively parallel streaming source that you have, you can use it and find out what are the sort of the underlying variables hidden there. And I think, again, it's a tool. I mean, you look at that. It doesn't give the variables any names. It just gives you the value for every frame, and from there, maybe you can, maybe we can start making sense of it.
I kind of want to run it on the entire universe and see if it gives the answer 42.
Yeah, right, exactly. It turns out
that would make sense.
Yeah, there's just 3 variables, and that's it.
Yeah, I mean, does it have, because we're kind of talking around an idea that's maybe familiar to us, but just to explore it for the audience, and that's Occam's razor, that the simplest ideas tend to be the correct ones. And so you said here that you kind of squeeze it down from 8,000 parameters it's doing great, but 4 it's doing almost as good, or maybe even better in some cases. I want to ask you about that. But how is it, are you manually telling it, no, 4 is better than 8,000, or does it somehow filter between those and apply its own Occam's razor?
It has its own Occam's razor. There is a clever technique in data analysis where you sort of you can find out what is the dimensionality of the manifold of a data set automatically. And the gist of it is sort of imagine that you have data that's really on a curve. It's in a high dimensional space, but it's really on a one-dimensional curve. So if you start at the beginning and you expand the sphere around the origin of the data set, as you expand the sphere, more and more data points are inside the sphere, and the number of data points grows linearly with the radius. So it's a one-dimensional
I see.
thing.
Okay.
If it's a surface, as you grow the sphere, the number of points included in that sphere will grow as a square.
Yeah.
So that gives you the dimensionality of the data set. It's a kind of a simple, very simple technique. It's well known. And so we do that with this data set, and it gives us the number 4. It gives a 4.2 actually.
Yeah.
But which means that this double pendulum maybe had a little bit more than 4 degrees of freedom. Maybe it was vibrating. Maybe it was the pixelation of the camera. Okay. There's some more to it, but you can actually get a very clean number.
It sounds like when you compare to the next 2 frames, in the machine learning parlance, you might call that cross-validation almost. You're checking the predictions and choosing between models, which ones make the best predictions. Right. You know, with cross-validation, we've often heard it argued, and I think it's, you know, maybe you have a view on this, that it kind of knows about Occam's razor already. If you take a very, very complicated model, imagine like fitting a polynomial of like 100 order polynomial, very, very wiggly line through 100 data points, it does beautifully. But the next point, it's, you know, polynomials are very unstable. They just go completely wild for the next data point. Whereas if you choose a 0th first order thing, it's very stable, right. And so it will make the simplicity leads to better predictions. And so cross-validation almost knows, it's almost built in.
Right.
So I wonder, you're only going 2 frames across, but if you go further and further into the future with these double pendulums, do you see any, does it still work? Do you see any differences between the complex models and the simple models in those cases?
Yes, actually, that's a great question. When you use the sparse model that has only 4 variables, it can generate future frames that look like it's much more stable in the long term. So but when you use 8,000 variables, it can generate very, very crisp images. Or maybe of a fake pendulum, but the images look really, really good. So you get if you use many variables, you get, you know, very good looking predictions that are not stable in the long term. You use a small subset or a tight set of variables, you get very stable long term predictions, but it can't do the high fidelity rendering. So we end up actually to do it well, we use predictions at all scales. So you use the 4 variables to know where the pendulum is, and to render it well, then you use the.
It's very powerful. I mean, the fact you can just quantify this number is pretty special. It makes me think of, in my field, obviously, in astronomy, one of the things we want to do is look for intelligence in the universe, life in the universe, and a techno-signature would be an information-rich signature, presumably, or many of the ones we might imagine, like a radio signal beamed our way with the galactic encyclopedia on board. And so it makes me wonder, have you thought, could this be used in some way as a detection algorithm for complexity? This is a system which you absolutely can explain with 4 variables. This requires a huge number of variables, and therefore there's some architects behind the scene here.
Right, I think so. I think that could be an approach, and you would need to handle the randomness issue. So you can, so if you're trying to model so you need to have built-in stochasticity, which the thing we've built that cannot handle stochastic signals. So, and that's really, really important. There's other techniques that are better suited for that.
You mean signals? So just saying signals with randomness embedded within them. Yeah.
So if you try to model a random signal and you don't know any better, you think, oh, this is very rich in information, whereas actually it's not. So distinguishing between random noise and information is hard. This is sort of almost the conundrum of information theory. If you try to compress a file of random numbers, very, very difficult, because it's very, very rich in information, but that information is useless.
Now, I have to ask you, what is your motivation? Because you've been on this journey for 10 years. Are you trying to put me out of a job and all the other physicists? What is in your view, the end goal here, that this would be a tool that we would all be using? Or, I mean, it's hard to imagine we would need as many physicists if this thing was in a fully realized version. So should I be worried about my job?
I don't think you should be worried specifically. I think there's plenty of things to explain. we're not going to run out of challenges of things to model. But it will allow us to model faster. And it would take away the sort of low-hanging, you just look at it and you say, oh, this is, you sort of intuit your way through it. I mean, it's going to take care of a lot of things that we can't, the easy stuff, and allow us to handle more complex things. I think we're sort of, I think we as scientists are sort of living in a very brief window of time where we, for most of human history, there was no math. You couldn't explain anything. That's it. It was all observational.
Just magic.
And that's it. And myth. We have math now for the plus sign was, I think, invented 400 years ago or something. So it's a pretty brief period that we have math and we have mathematical tools and we can explain things. But I think we're reaching a point where, it's even with the math that we have, it's very difficult to explain things. And maybe physics can last for a little bit longer, but you look at things like biology, I mean, it's kind of hopeless. The complexity there is so enormous that and that it's really hard. So these tools that we're developing, I think, can help us, extend that window a little bit. But in the long term, if you're thinking, long term for me is 10 years in AI. AI is for sure going to be able to understand things that we humans, are just incapable.
Yeah, because you could imagine a world where you can almost take the scientist out of the whole process. You could have the observations being taken by some automated robot, we've had robotic telescopes, for instance, very common. Our survey satellites are all roboticized. So the data comes in robotically. It could be analyzed with tools like you're developing with Eureka and other derivatives. And then the scientific publication could be written by ChatGPT.
You're right, that's right.
The figures could be generated by, maybe some combination of like Dolly 2 or something.
That's right.
And then even eventually the presentations will just be done by
by a robot.
By machines. So,
but we'll need, there is something where I think we'll need is a tool that will be able to explain this to a human. To say, okay, this is a very complicated model. It's very accurate. It's very predictive. We know it's true because it matches with future experiments and all this. And here's the gist of it. It's very complicated, but here's the whatever level you're capable. And maybe at some point it's going to be too complicated. And we just, it's like explaining Shakespeare to a dog. I mean, there's no metaphor you can.
It's no common language.
There's no common language. But I think for a while, for a few centuries, we can, I think, hang on and understand.
So we'll be moving towards almost interpreters.
Yes.
Interpreting what it discovers.
Exactly.
And translating it.
Exactly.
Yeah.
I think that's the role of future, scientific AI is to explain the complex models that AI does understand in human language. I mean, in a way, ChatGPT is doing a little bit of that. So if you think about it, ChatGPT is a model that has read the entire internet and understands the entire internet in one brain. The entire internet, that is unfathomable. It's read everything. You can ask it about everything that's out there, and it has read it. But when you ask it a question, it spits out some explanation that you can understand. And so it translates this entire model, whatever that is, with 175 billion connections into human language that you can understand. So this is, I think, a translation. And I think that's the future of AI and science, that intersection.
Yeah, it's really been incredible to see these new tools. It does feel like, for the last few years we've been seeing AI do more and more impressive things, but the last 12 months has felt particularly accelerated. It feels on the outside of this world like we're on the cusp of something, like something is changing in our society with AI potentially becoming truly integrated in the way we use it in everyday life. that's how it feels from the outside. But as someone working in this field, are we getting too sensationalist about these new technologies that are coming online?
I would say on the contrary.
Okay.
I think people generally underappreciate how fast this is moving forward. You have to remember GPT-3, for example, the thing that everybody's talking around about, and that can solve our final exams. And in my class, it got above average. I saw in your class it got slightly below average. In my class, I copy-pasted the questions, it got above average, slightly above average.
Yeah.
But you have to remember that tool was released, was trained in it's a product of the 20s. It's 2020 technology. GPT-4, which is already in existence right now, is much better. And I think people talk about what is ChatGPT-3 going to do to the world. They don't understand that that's all technology.
It's already obsolete.
It's already obsolete. I mean, and these things keep getting better. So we humans, we don't get better with time. I mean, if you look at a previous generation, this generation, we're probably roughly the same level of intelligence. We're exposed to more data and so on, but our sort of probably intellectual capacity is similar. Whereas these systems keep improving literally exponentially. And so I think people don't appreciate what it's going to be like in 5 years, in 10 years.
And does this scare you? Do you feel, a lot of people might feel uneasy about living through such a potentially dramatic transformation? As someone, you are one of the architects of this transformation, do you ever at night think maybe I shouldn't be doing this?
Well, I'm watching the videos on this channel and thinking there's a lot of similarities between seeking extraterrestrial life and this endeavor. So, if somebody told you, okay, if you go on there, do this thing, you are going to meet an extraterrestrial intelligence. Do you want to do this? And the same thought that
Sure.
would go through your mind is what I'm thinking, except that I think whereas
because it really is another intelligence.
it is another intelligence,
Yeah.
and would you do that? I think the answer is of course. You would hit that button and say open the door, right? Even though this is scary, the implications are transformative. There's no way back once you do this. But how can you refuse this? I mean, again, I think the benefits far outweigh the risks of having this kind of tool, this kind of intelligence to work with. But absolutely, this is something. This is not a trivial moment. It's very exciting. It's terrifying, but I think it's going to happen. And this is what I think people don't understand. This is happening very fast. And it's going to be a pivotal moment in
human history.
Human history. People have written about this as the singularity in the terms of sort of computational, Kurzweil, in terms of stuff in computational singularity of intelligence, and I think that's really we're getting close to it.
And I'm a parent of 2 kids. I don't know if you have children or not, but I'm curious. What do you think we should be? We always tell our kids, study hard at school, learn your mathematics, learn your humanities. But there is a sense of futility sometimes when we saw it with the final exams that we've both tested. What skills would you recommend the young generation of people who are in learning right now? What skills should they be focusing on to be best well suited for this new wave of AI that's coming?
Yeah, that's a great question. I'd say this is probably the question I get the most when I talk about AI is people wondering, what should the kids learn and how should people prepare? And I have 3 boys, and the same question occurs to me.
Yeah.
The older boy, first of all, none of them ask me. All right, so this is all hypothetical advice.
Me neither. Yeah.
Okay, but the older one is studying AI, which is at least he can hang in there a bit longer. But the younger ones, I would say, look, there are certain things that AI right now cannot do. And I'm not saying it will not be able to do, but I think it's a little bit down the road. Certainly good enough that you can still, the humans will still dominate there. One is physical work. And this is a bit counter what you normally hear. But I think intellectual stuff, machines are going to dominate very quickly. But when it comes to physical stuff,
so the robotics is behind
the robotics
software.
is very much behind. So an AI can drive your car tomorrow, but when your car breaks down, it's going to be a human fixing it. I can't imagine a robot crawling around fixing a car. It's not a satisfying answer, but plumbers are going to have jobs for a long time. I mean, here in Manhattan, a plumber already makes per hour more than a software developer. Anybody, if your hands are dirty, your job is safe. It's the trades. So plumbers, electricians, hairdressers, nurses, surgeons, as opposed to radiologists, anybody who works with their hands.
Interesting.
Okay.
Yeah. So we should be training a generation of plumbers. Okay.
so we might have to rename it, give it a little bit more, make it sound a little bit better. But yeah, these things. So I can say robotics is very, very far behind for many reasons. It's a very complicated thing. It's one of these things that we've learned to think about physics. We've been thinking about this for maybe 1,000 years, but we've been using our hands for millions of years. So we are just so good at it. We don't understand how good we are at these kinds of things.
Now there are, maybe to try and defend human intelligence a little bit, there are many facets to intelligence. There's emotional intelligence, which you might imagine being something more challenging for a machine to duplicate as convincingly. And another one, maybe come back to the Eureka thing a little bit, is seeing generalization, unification across fields. You could, Maxwell kind of famously did this with electromagnetism. He saw, there was certain equations that governed electric fields that were similar to magnetic fields, and he was able to connect the dots and realize there was Maxwell's beautiful equations which unify electromagnetism. And of course, physics is generally on a quest of unification, trying to understand things. Is that something that, it seems like obviously Eureka is not at that stage yet, but are there aspects, maybe that's a bad example, but are there aspects of intelligence that you think will be particularly challenging for, whether it's some form of creative expression, some emotional intelligence, generalization? Are there aspects that it will struggle with?
The physical work is the one thing. The other thing that I wanted to mention is exactly that, is that emotional connections with humans. So so this is a place where we have an unfair advantage as humans, and when I use that unfair advantage is that it's easier to connect with another human if you are a human. You have a lot of shared background. I can sort of I can make this a very simple assumption that the pain you feel I can feel the same kind of pain. And we probably feel the same kind of pain. We feel the same kind of joy. We probably have the same internal architecture. And so that assumption is something that builds empathy that is very hard to have with the machine. So the other thing that I think machines have a hard time, and will have for a while, is have a conversation. And I know that GPT can write essays and poems and can sort of answer questions, but having a conversation about nothing, like a idle conversation, is the hardest thing. I mean, it involves...
So small talk, basically.
Small talk. It involves rapid understanding of things, taking in cues, body language, eye contact, emotion, shared background, humor. I mean, there's so many channels at the same time, all being processed very, very rapidly, and require a ton of intelligence. Again, this is not normally what you associate with intelligence, but again, it's because we are so good at it, we don't appreciate it. But having a conversation, not again a lecture about some topic where you've rehearsed and it's a one-way street, but a back and forth, rapid conversation, unprepared, spontaneous, not something you can look up data and regurgitate, but you have to sort of respond. I mean,
So podcasting is the future of a career.
so exactly. So that kind of thing, I
Yeah.
think, is going to be very hard for machines to do for many reasons, and it brings in all these extra emotional intelligences that are not just number crunching and so on.
Right. Yeah, because I was thinking about this with performances, of course. Lectures is a form of performance. But you know, already so many actors are being digitally replaced or augmented in their performances. You see it obviously in the music industry. The performance of the singer is often severely edited
Right.
with auto-tuning and things like this. And so we're already kind of halfway stepping into that world of, well, why do we even need the performers in the first place? Presumably a machine will have already, I would think, be able to sing better than any human being could sing.
Right. That's for the one-way career graph. Again, but for the spontaneous interaction, that's still very hard.
Yeah.
And not to say we're not working on it,
Yeah.
but I can see it's very, very
It's
hard.
further down the road.
It's much further down the road. And again, when you look at AI, down the road could mean a decade or so. But I think that's that's not very satisfying in terms of what's the future of the human race. But I think
It's terrible. You say it's short for you. 10 years is short in a career sense, but long in a career sense, but it's short in our lives.
Very, very.
And so
It's
I know I will see these things, and that we all will.
That's right. I mean, this is what is exciting to me about this. But yeah, on an astronomer's scale, that's like not
nothing.
even. There's
Right.
no unit for this. Yeah, but
Right. So let me, because we're kind of getting close to this idea of AGI, general intelligent machines and consciousness and things like this. And I saw you were quoted recently in the New York Times on the talking about this, and I think you said that in the early 2000s there was sort of a culture of don't say the C word,
Right.
which I had to take a double take to figure out what you were talking about. But, it was consciousness, and so it's becoming now. People are interested in the idea of truly AGI in conscious machines, and that raises all sorts of ethical implications. It's one thing to have a tool which can parrot back to you in a way which seems like it's intelligent, but it's just a series of nodes emulating that intelligence. It's another thing ethically to create something which is in essence a new life form, a new intelligent sentient entity. How do you feel about this from an ethical standpoint? If you had the capability, you had all the nuts and bolts in place in your laboratory, you were ready to push the button to connect them and create the first AGI, would you feel comfortable doing that? Should there be some laws, some federal governance about who can create this, or are we overthinking the implications?
There's a lot there in that question.
Yeah,
a lot there in the question. Well, first of all, I want to emphasize that. So, one of the things that I'd say the thing that we're working in our lab is this quest for artificial consciousness, for a machine that understands what it is, and that is different than AGI. So
Okay.
a cat understands what it is. Okay, but it's not a threat to humanity.
Right.
So I think this is a very different thing. AGI could be a brain in a jar that doesn't have no consciousness, but can answer any questions and can design things and can solve problems, and that I think is a big deal. Sort of a GPT 10 that can do everything. That is not necessarily self-aware, but that's the thing where you need to have this discussion, I think.
Could you have AGI without consciousness?
I think so.
Yeah.
I think GPT is a great thing. It's very general. I mean, ChatGPT already answers questions about anything from philosophy to shopping lists to whatever. Very general intelligence, but it's not self-aware.
Okay.
And then. And the kind of things we're working on is the self-awareness, which I think is very separate. Again, a dog is self-aware in a small way, and a mouse is, and humans are, and there's maybe higher levels of self-awareness that we can't think about. But that's a different it's a different question. So now the big question of whether we should do it or not, and whether it should be regulated. The answer is for sure yes. I mean, this is such a powerful technology. It's just hard to regulate it because it's moving fast and because it's very, very. It's just very fluid. It's not a nuclear reactor where you can see it. I mean, it's just. So it's very hard to regulate. And I think that instead of thinking about regulation, what we really have to think about is that everybody has to be involved in this decision to move forward. This is why I'm talking to you. This is why I'm talking to New York Times. I think this should not be done behind closed doors and be revealed. It should be something that we all engage in.
Participate in,
and participate and discuss and understand the power. It's also important to understand that it's not going to happen immediately. It's gradual. So we've all seen ChatGPT 3. We got a taste. We're going to see ChatGPT 4 when it comes out. There's time, but it's moving, and we can't just sit back and relax. We have to think about this. And there's pros and cons. This is fire. This is like any technology, pros and cons. I certainly have come to terms with myself that the benefits outweigh the risks, but we should do it carefully. This is sort of my feeling, but I'm not pretending that this is like a trivial thing that we just let the scientists take care of it.
So there is something unique and well, there is something to distinguish between consciousness and AGI then, but the combination of the two is perhaps the most potent thing that would be in our minds.
That's right.
That is really dawning a new civilization potentially that's going to coexist with us.
Exactly. And that to me is, again, the thing that's most exciting and terrifying at the same time.
Yeah.
It is exactly like opening the door when you've arrived at this exoplanet that has intelligent life. It is sort of irresistible in a way to do this, but the consequences are profound. And I think, we'll have a little bit more control over this, but when and how we open this door, it's a little bit more gradual than an alien invasion.
Yeah.
And we do have, I think, a decade or two to sort of control how this is going to unfold. But it's, look, to me, personally, I've always actually wanted to meet an alien species as a child. I've read, Bermuda Triangle and whatever, any book and movie that you could find about extraterrestrial. I think, I don't know if that will ever happen. It's a matter of belief and faith, but I think the alternative is to create this intelligent species, and this is what's happening. And this is the alternative, and I think it's going to be just as exciting.
It almost feels like a question of futility at this point, because even if your lab shut down and you made the ethical decision, okay, I don't want to do this anymore, it's everywhere, and there's so many groups all over the world developing this that it's a ticking time bomb at this point. It's going to happen in the same way that probably you can't really prevent the invention of a nuclear weapon. Even if the Manhattan Project had been abandoned, it would have, of course, eventually have been discovered elsewhere. It's within our capabilities to do so, and it's, as technology gets, if it progresses, it becomes easier and easier to manifest this. And so we are really talking about the end of the intellectual premiership that humanity has enjoyed on this planet for the last million years or so. Very speculative, but what role do you see for the future of humanity in a world where we are no longer the intellectual kingpin, and not just by a small margin, but potentially by a vast margin? What is our role and our relationship with the AI?
I think you said in one of your previous podcasts, sometimes you just have to say, I don't know. I mean, this is a little bit of this is the problem with, I think, singularity. It's very hard to predict what's on the other side of it. It's just such a, there's no derivative that can go through this thing. I mean, it's a completely, there's no linear projection that can tell you what's on the other side. So again, the good news is that it's gradual as we get closer, and like you said, there's many forms of intelligence, and yes, it's going to be very good maybe at in creativity. I can already, but it might not be good in conversation, in empathy. It might be better at this, and so I think just like we have so many different species already on the planet. It's not just humans and animals. I mean, there's different species, and they all are good at different things. And bacteria are good at some things, and dogs are good at other things, and they can smell better. And so I think there's going to be lots of different AIs. They're going to be good at some things and less good in other things, and it's going to be an ecosystem. And we really have to think about it as an ecosystem that's going to co-evolve with us. That doesn't answer your question. What happens in the long term when these things continue to evolve?
I guess I was kind of wondering if you were thinking along sort of the Musk route of like augmenting our intelligence, or trying to keep up with them, or whether we should really just abandon that and would be more living as pets or something as compared to them. There are obviously ways that we could change the intelligence of the brain hypothetically with these chips that Neuralink are trying to develop, but many of us are kind of deeply uncomfortable about the idea of putting something in our brains to try and keep up with AI.
I would, again, maybe I'm a conservative here, but I would rather not have the AI implanted. I want to be able to rip it off and turn it off, at least to disconnect.
Yeah.
And I feel that once it's inside your body, you cannot disconnect, and this is to me terrifying.
Yeah.
But that's, there is going to be a very long period where we coexist and we co-evolve, and this is to me the sort of the techno-utopian version, is that we just co-evolve with this intelligence, and good things are going to happen. And people are worried about jobs. I think in general, as long as we have problems, we have jobs. As long as there's things are not right, there's jobs, there's work to do, and that's going to remain the case for a long time. So I think, I'm cautiously optimistic.
And maybe just to lead us into the astronomy world a little bit further, and get the big picture with what we try to work on, which is the search for other life in the universe. We are potentially creating a new life form on Earth with these AIs. Does this imply, because it is a short time scale, I mean, on an astronomer's perspective, it's a very short time scale, that we're going from the dawn of civilization, the Neolithic revolutions of 10, 20,000 years ago, and within that very, very short period, you transform from hunter-gatherers to AI. And the idea of catching someone in between then seems extremely small.
That's right.
So when you think about the Fermi Paradox, the search for life in the universe, to you, is it really binary like that it's either dumb life, which is probably primarily like single-celled life, but maybe some examples of multicellular life forms out there, and then just other worlds that are just totally dominated by AI?
I've thought about this a lot, and I think it has to be. That has to be the case, that your odds of finding civilization that is intelligent but is not dominated with AI is zero. Because that is such a brief period. And once it dominates, it's then you're going to be communicating with the AI, you're going to be greeted by the AI, you're going to be the whatever you see in a visiting spaceship is going to be an AI. I mean, it's not going to be the wet aliens in there. And again, this is I think that's it's not as romantic as going to another planet and opening the door and being shaking the hand of a
Vulcan.
but I think this is where we got it wrong. This is where a lot of the sci-fi movies got it wrong, and that it has to be AI. Now, I'm hoping that there is again the utopian version, that there's some coexistence, so that AI does lead you to the wet organisms somewhere down the line. But I think that the first encounter for sure is going to be a machine.
Wow. And that to me sort of opens up two speculative implications. One is that this AI would have very little interest in communicating with us, because our intelligence would dwarf them by such a huge degree that we really won't be able to teach them very much from our own intellect. But on the other hand, they might be particularly interested in us from an anthropological perspective, that we are caught in this very narrow window in time, this transitional period that very few planets exhibit, right? Even if intelligence is common, which I don't know, maybe there's no one else out there, but if it is common, we would surely be rare amongst those by being in that window.
Right. We're a rare fossil.
Yeah.
Okay.
So there would be an impetus then to study the Earth extensively over as we make this transition, to perhaps glean insight as to what their own transition may have been like.
Which leads credence to this hypothesis that we are being observed, but not just
right,
not interfered with. I mean,
the zoo hypothesis.
Yes.
Yeah, the zoo hypothesis was in fashion, I think, probably in the 70s and 80s a bit more than it has been for a while. But I think when you look at this transformation that's happening, it does naturally make you think about that again and take it more seriously.
But here's the thing that to me I think is sort of the end game, is that I guess more of a hope than a real thing. But I think that all this quest for extraterrestrial life involves a lot of technology. It involves telescopes, and it involves rockets and propulsion and all these different things that we have to invent. And we are just cavemen trying to invent an antenna. Okay, this is really, really hard. We're really slow. We're not doing it efficiently. We think that you can only communicate at this speed and in a linear way and whatnot. But maybe there's more ways to do it. And so I'm hoping, it looks very difficult, but it could be that we, again, not going to happen tomorrow, but if we have an AI that's good enough in understanding signals and so on, it can find ways to communicate and see things that we can't see. I mean, we humans are so limited in our senses. I mean, we can only see such a narrow spectrum, and we have all these machines to help us see in a slightly broader. But if you have an AI that can see in wavelengths we can't see, and hear in frequencies, and go places we can't go, and understand the world in ways we can't even begin to understand, maybe the solution is actually a lot simpler.
Yeah,
and the door will open. I mean, I think we'll. There's plenty of things we don't understand, and I always feel like instead of trying to figure all this out, let's build a machine that will figure it out.
I mean, that's kind of the dream. And I have to say, when I think about AI, that's the thing I'm most hopeful about, is the idea of AI inventing solving the problem of nuclear fusion for us, or developing a faster than light spaceship, or whatever it is, a teleportation device where we don't have to fly across the Atlantic every time I want to go home. So, those kind of things would be incredible. And I know AI has obviously been used. We talked about Eureka, and it's been used. I have colleagues who work in, some friends back home who work with like racing car design, for instance, and they use AI to design the shape of the fins and the aerodynamic foils. But that's really kind of modifying a modification of existing technology. Yeah. I don't think there's an example of this. Maybe you'll correct me if I'm wrong, but it's what I really want to see AI do, is to invent something that a human mind has never conceived of. Right. And then that would to me be the game-changing
that's
moment.
Right. And that has not happened yet, I agree. But that's the hope. And I think when that happens, and this will open doors that we can't even imagine, like quite literally. And I think that's, to me, that's the benefit. This is why I think we should pursue this with caution. But I think, again, the rewards are enormous, and it's not just that. It's curing cancer. I mean, it's whatever it is that you care about. I think machines will eventually be able to do that better. Now, we still have to work on these things because we can't wait. But I think, again, the benefits are enormous. And you can already, I think, see things like, medical diagnostic being done by AI better than the average doctor. That's already a huge benefit. But this is only going to improve.
And I mean, have you attempted to use the tools you're developing in the world of medication and health?
Our group has not, but many people have. There's many companies doing this. I mean, medical diagnostics is almost anything that you can get data for, the AI can do a better job than a human. So it's more of now the question is develop the sensors,
Right.
and let the AI do the diagnostics. And this is and I think this is the same thing is going to happen with science. Develop better sensors, develop better ways to collect data, and let the AI do the rest. And I think this is and once we get there, we'll learn things that we just are right in front of us, but we can't understand. And I think there's a lot waiting to be discovered.
Yeah, there's all sorts of solving the problem of aging, or curing various diseases.
I mean, it could be. I mean, if you're an alien species, this is a completely fantasy. But if you're an alien species, you embed a signal that can only be discovered with AI, and so that just keeps. It's a gate, and when you reach a certain level of AI, the door opens because you can understand the message, and that's it. So I think there's a lot. I think there's plenty of sci-fi. Carl Sagan had that thing in Contact. I mean, there's the embedded messages that you need to be intelligent enough to.
But it almost sounds like you're like a prime directive from Star Trek. In Star Trek, they do not make contact with other civilizations unless they've discovered warp drive, right? That's kind of the gatekeeping level.
Thing, right.
And so here it may be that it's an AI or some higher plane of intelligence that we're yet to ascend to.
That's right.
Yeah. Well, there's some hope there, I guess, for the future. I'm trying to keep my optimistic hat on, and I think you've given me some reason to be more hopeful.
I'm so optimistic about this because there's so much to discover that we just can't. I mean, we tend to think that we humans are so great and we understand, but our brains are limited, and we are mostly occupied with breathing and walking and doing things like that. And so having a tool, a companion that can understand the world and tell us what's going on is going to open so many doors. And this is a great time to be alive.
Well, you got me excited again. Okay. Well, thank you so much, Hod. This is a wonderful conversation.
My pleasure.
I've learned a lot about AI here, and be sure to check out, you've got a YouTube channel you've recently started where you're talking about some of the work you're doing. That's just your name, I guess, to search for. So let's check that out. And as always, thanks everybody for checking out this episode.
Thank you.
Cheers.
So that was my conversation with Hod Lipson. I hope you enjoyed it as much as I did. It was a conversation that was frankly equal parts terrifying and exhilarating, thinking about the future of our society as these intelligent machines and software packages become integrated into our society. I think it's clear that we are living through a transformative period in the history of humanity where, for the first time, we will make a tool, a computer, that will have an intelligence level comparable to our own, and eventually, surely, even greatly exceeding that of our own and even potentially the entire human race. That raises some profound questions about what we will do with this new tool. But there's also some reassurances, right? We could use this for the benefit of humanity. We could use this, as Hod is trying to do, to rapidly increase our rate of understanding of scientific phenomena, to understand the world around us at a pace that would be impossible through human endeavor alone. At the same time, there's opportunities for breakthroughs in medicine and health and the future of our own well-being as a society. We have to think positively about these tools. Like any tool, they can be abused, they can be misused, and I think that is ultimately the main threat of AI. It's not the AI running rampant in a Terminator 2 style world of Skynet taking over. I don't think that's probably the most realistic case. I think it's more likely that the threat of these tools comes from individuals, bad actors, human beings misusing them to persuade, to misinform, to potentially even hurt other humans and large parts of our society. That's the danger we have to be careful of. I think, though, there is a lot of hope that these tools could be a major force for good, as well as potentially something that we have to be cautious about in their misuse. So I hope you enjoyed this conversation. I hope you enjoy these podcasts as we have these challenging conversations. If you do, then you can support the Cool Words podcast by going to coolworldslab.com/support. That's coolworldslab.com/support, and you become a member to both my research group, the Cool Worlds Lab, but also all the outreach work we did, including the YouTube main channel that we run. So thank you for your time today. Until next time, stay thoughtful and stay curious.